Hey dear students, today we learn the equations of motion for when a body projected from a top of a tower. So general equations of motion, this v equal to u plus at, s equal to ut plus half a square, v square minus u square equal to s, sn equal to u plus a by 2 into 2n minus 1. This is general equations. Now the body projected from the top of a tower. So let it be take one tower here. This is top of a tower or top of a building. So now the body is projected from here. It will reach, and after that it is falling to the towards the ground. Let it be. So that means the point initially body projected u meter per second. To reach this point is the maximum height, and after that it will strike the ground. Here final velocity also there, initial velocity there, final velocity there. So while projecting upward, so initial velocity will be taken as a positive. So acceleration is against gravity minus g meter per second square. So displacement of this one will consider as a h. So now from first equation of motion, v equal to u plus at. So after 1 second, 2 second, 3 second, like v is equal to u minus g into t. But here time depends on the projected projection time. So if projection time is less than u by g, less than u by g, less than u by g means body moving upward, body moving upward, body moving upward. That means it's moving upward. So if projection time is equal to u by g, then body reach maximum height, body reach maximum height, body will reach the maximum height. So if projection time is greater than u by g, then body come back towards the ground, and if projection time equal to 2u by g, then body reach the point of projection. So that means see here. So in this, body is projected from here and to reach here. So this is till to here u by g, less than u by g. This is u by g, say greater than u by g, and this point is equal to 2u by g. Time of flight this is. When it is hit the ground, it has a final velocity, that is v is there. Okay. So that means the body will reach the ground. The displacement should be minus h. So when a body is dropped from the height h, displacement is minus h. Okay. Then here come to the second equation of motion. This is important. Most of the numericals based on this formula only. So S equal to ut plus half at square. S is nothing but a minus h displacement, ut plus half a nothing but a minus g into t square. So minus h equal to ut minus half gt square. So half gt square minus ut minus h equal to 0. Then gt square minus 2ut minus 2h equal to 0. From this quadratic equation, so we can find the time intervals, time values. So this is the second equation of motion, and the third equation of motion. Third equation of motion. Third equation of motion. So v square minus u square equal to 2as. So v square, that is u square, plus 2 into minus g into h. So then v square equal to u square minus 2gh. Then we need to find v equal to under root u square minus 2gh to finding the velocity over here. And then fourth equation, displacement covered by n second. Fourth equation of motion. Fourth equation of motion. So Sn equal to u plus a by 2 into 2n minus 1. That equation can be written as hn minus u into minus g by 2 into 2n minus 1 here. So minus 2hn, that is 2u minus g into 2n minus 1. So g into 2n minus 1 minus 2hn minus 2u equal to 0. So you will get the u value here. So these are the equations when the body projected from a top of a tower. The first one, v equal to u minus gt. Second one, minus h equal to ut minus half gt square. Third one is v square minus u square equal to minus 2gh. And fourth one is minus hn equal to u minus g by 2 into 2n minus 1. So these are the four equations. Depends on the numerical